I don't know why. Okay. This is such a confusing thing. Stop. 95th percentile. What is... Okay, so this is the smallest value such that the probability that x is less than this value, the probability that you will get less than 68, the probability that you'll get 68 or less, equal to, it says equal to, it says the probability that you get 68 or less. The probability that you will get 68 or less is more than or equal to 95%. The probability that you'll get... What are we trying to do? This is stupid. We did part A, which was 2. Part B is 4. For some reason, they're being stupid. Like, they want you to use trial and error. This is 2. This is the number of systems. 1 system, 2 systems, and 3 systems. I don't know what is up with these. These are not supposed to be like this. I'm just going to delete these. What on earth? What? What? This is messed up. This is totally messed up. What? Where's table? Equals... What? This is so messed up, man. N equals 3 is more than enough. N equals 2 is not enough. Like, yeah, trial and error and all that crap. Wait, so 0.9999. I don't know how this table works. Why can't I just delete that? What the heck? Why? Just why? I can't even delete it. This is hilarious. You know what? Stop. the probability that you will have more than 0 successes with one trial, probability of 0.98, true. It's literally just 1 minus binom.dist. You will have more than 0 successes with 2 trials, 0.98, true. 1 minus number of trial. You'll have more than 0 successes. You'll have 3 trials, 0.98. It literally tells you the answer for you. Like, what the heck, dude? I believe I did this correctly. I was very unsure of it, but I think I am doing it correctly because it's consistent. This answer here is consistent with this. Like, 2 is not enough, obviously. It's not 0.9999. It's only 0.9996. 3 is enough. 3 gets you 0.99999. Stop. So, yeah. So we're done with that one, I think. We're done with number 28. Number 28 is done. 28 is done. We are done with 28. 28 is done. We have done 28. We have done 3 out of 10. Funny. We're done with 3 questions out of 10. Wonderfulness, everybody. Number 33. We're on a... Shut up. Number 33. Number 33 is the next question. Number 33. Number 33. Number 33. Smith. Wait a minute. There's no way we already did this. They're just using the same, information. We did something with the same idea, but now they're asking you different questions. Smith. Like, if I go to the next page, are they going to have another Smith question? No, it's probably at the end of the chapter. But anyways. This was a fun one. I was so confused by this before. Random sample of 100 voters. What's the probability that the sample indicates Smith will win the election? Jones, 50-50. So yeah, this is pretty straightforward. Just gotta... We'll go to the sample. So they're like probability of having at least, this is the proportion. There's this many trials and you get this many successes. That's how you think of it. But your chance of success for each success is this. So, yeah. Yeah, I've done it. I did this, basically this same type of question yesterday. Proportion, probability. What's the probability that you'll get at least 51? What's the probability that you'll get at least 540? Well, it's 540 minus 1, remember? Because you do 1 minus blah, and you have this minus 1. So the probability that you'll get at least 51 out of 100. So if you're doing a greater than problem, you do 1 minus binomial. Number of successes. The number of times you're going to get. You do 50. You do 50. That was fine. 50 trials, 100. Probabilities, 0.53. True. So the probability that you're going to get that's... Now, why was I getting such a high percentage at one time? Man, I'm getting worried. Oh, I probably did the project wrong, man. What? How did I get this? This is kind of what I did on the project. It's almost not different. It's almost not even different from the project. How is this different? Why am I getting such a different result? What was the question? Which one was it? Great, I don't even remember. Probability that you have Man, I got such a high number here. What? How did that happen? Like how? I got like 98% here. It's like the same type of thing. Half of 1500 is 750. So at least this is the probability of getting less than 750 first. Probability of at least 51. Why does it change so much? I'm gonna do like the same exact formula. 1 minus maybe the more trials you do, the higher the percentage you're gonna get, or something like that. Oh, I'm an idiot. It was 1500, not 1000. Like, the more trials you do, the more certain it's going to be that you're going to get exactly 53. Or you're going to get... Because you only had a sample of 100. That means the probability okay, so equals 1 minus binomial. Number of successes is that minus 1. Number of trials is 100. Now your probability, your actual probability is 47%. 47%. Your actual probability. Right? Assuming there's no other kids. Your actual probability of getting at least 51, because this is basically more than 50, so that means you're going to get 51. So more the probability of getting more than 50 with 100, and your probability is 0.47 because it's 1 minus 0.53. So that should be right. What's the probability that that's going to happen? So like 1 out of 4. What's the probability that the sample indicated a 50-50? Okay, so that's pretty straightforward. You have equals binomial. What's the probability that you're going to get exactly what 50 successes. 50, you're going to get 50, 100, 0.53. Like, what's probably that? You have a 50.3, and you're going to get exactly 50, and you're going to have false. Naomi, that was funny. What else was funny? We have so your probability of that happening is like 6.7%. That's fine. Interesting. Equals the sum of this. Because those are all the possibilities. That's kind of a nice thing that they have here. What is the probability that between 40 and 60 will prefer Smith? So what's the probability? So I can look at like a different example here. What's the probability of having in between this many? In between 55 and 65. So you basically do the higher one minus the lower one, but for the lower one, you actually do you do this minus 1. It's the higher one minus the lower one, and then you do the lower one is you do that minus 1. So equals. So the higher one is 60. I have 100.53 true minus binomial dot dist. 40 minus 1 is 39. So the probability that you're going to get in between 40 and 60 is 93%. So that's good. We're done. We're done with 33. That's it. 33 is done. That's 33. 33. We're done with 4 out of 10. That was so fun. Hilarious, everybody. It is now time to do... We have already done these 4, now we are doing 37. Height of typical American females normally distributed with a mean of 64 inches. That was funny, 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 that was funny. That was funny, that was funny, that was funny. That was funny, that was funny, that was funny, that was funny, that was funny. Hold on. That's 5'4". Dumb. A value of mean value of 64, standard deviation of 4. Number reserved 500. What is the probability that fewer than 35 of them will be less than 58? Just tell them. I don't get why we're doing a binomial distribution here. That was funny. Why is this a binomial? Because like in the last problem, it was like either they win or they don't win. No, it wasn't. What the? I just realized. Okay, so we're doing... So I guess it's a chance of success or something or other. Yeah, this is confusing. I don't know what is the point of using a binomial distribution. I don't think we're supposed to use a binomial distribution for this. This is supposed to be... This is a normal distribution. What's the probability... So we're doing a normal distribution here. What's probably of less than 58? I almost did that norm. 58, 64, 4, 2. Probability of fewer than 35 and less than 58. I keep doing binomial. God. Dang. Like, I don't think this is correct. Hold on a sec. Because this is just like the probability that any 1 out of 500 will be this. So that's not right. Man. How do I do this? Great. Part A is, what's the probability that fewer than 35 of them will be less than 58? I feel like, isn't part B? Isn't part B the thing you're supposed to do first? I feel like part B is supposed to be first and then A. Oh. Oh, come on, I'm so confused. Man. Dang it. The probability of more than 0 being a success. There's 400 and its probability. Don't you have to do like 2 different steps? Like this is kind of a similar problem. Mean of this, standard deviation of this, probability that they spend at least 100 is this. Then you survey 500 customers. So the probability that you will have that probability that a customer will spend at least $100 is this. So you have to do 2 different calculations. Like they don't even show you the other calculation you're supposed to do before this one. I'm pretty sure. Probability less than 58. What is the probability that fewer than 35? Oh, I get it. This is the intermediate calculation. Okay, so I was correct in what I was doing initially. I was just got confused. So, what's the probability of getting less than 58? The probability of getting less than 58 is this. That was funny. So there you go. The probability of getting less than 58 is that. Now what's the probability of fewer than 35 out of 500 getting less than that? Oh my god. It's fewer than 35. So what's the probability that fewer than 35 will get this? The probability that you have less than 35 the probability that you have less than 35 with 500 with the probability of this and then true so there you will have so I got it a 2 final bosses. Wait, no, what? Well, aren't there 2 final bosses though? But this is not the actual second final boss. Maybe not. That was stupid. It's like 1, 2, 3, 4, 5, 6, 6. So there's not 2 final bosses. There's 1 final boss, and then there's 2 extra stages. That's funny. What? Let X be the number of 500 women who are less than 58 inches tall. The number who are less than 58. Find the mean and standard deviation. How do you do that? How do I find that? Okay, so what they do the number of customers times the probability. No. Wait, what? That's insane. That really? All you do is that? You multiply the number times the probability? The original probability? That's it? Wait. Where's the one thing? Yeah, that's it. It's just the number multiplied by the probability. That's it. It's very simple. So, standard deviation is the square root of NP multiplied by 1 minus P. Great. So, like, if we go back to the example, how do they type that into thinking? Oh. It's the square root of the mean multiplied by the probability multiplied by parentheses 1 minus the probability. So now this is where it'd be useful to have another page. Oh. That was fun. This is where it would be helpful to have both things open at the same time. Oh crap. So for that one, what you do, the mean, you do the number times, they did number of observations times the probability that they will do that thing. Okay, so equals this times this. Wait, hold on. It's times this one, right? The mean is 33.4. Jeez. Really? That can't be right. There's no way that's the mean. That's not real. That's not how it really is, right? Maybe. I guess of all of them who are left, that's the mean. And man, it's gonna be stinking. It's gonna be so fun to type all that stuff. So it's square root n times p. This times this times parentheses 1 minus p. So I think that's good. That was fine. We are done with number 37. We are done with number 37. We are halfway done, apparently. Well, I mean, it's only 3 p.m. I mean, give me a break. All right, give like. $44. Dude, they're like, use trial and error to solve part E. Man. Probability of exactly 12, probability of getting less than or equal to 12, probability of more than or equal to 15. Let me just make sure. Probability of exactly 12, probability of less than or equal to 12, no more than 12, so it's 12 or less than or equal to 12, probability of more than or equal to 15, and probability of between 10 and 15. So for that, so first of all, your standard deviation is this. Shouldn't you calculate standard deviation first? Is that required for these? Isn't standard deviation required for these calculations? No, it's not. What did I need standard deviation for before, anyways? Probability of less than, probability of equal to this, probability of less than this, probability of more than this. Greater than 3. Probability of greater than 3. So probability of 12, mean is 12, not cumulative. Probability of exactly 12. Probability of less than or equal to 12. So 12, 12, true. Less than or equal to 12 is that. Probability of more than or equal to 15. So 1 minus. So this is going to be probability of more than x, not equal to x. More than x. So it's 14. Right? It should be that. Because if you want to get the probability of more than something, oh, come on, man. They didn't do any example. Man! I bet I didn't do it right before. Yeah, because they did. Like, you do more than 14. So 15 equals 15 or more is equal to 12 or less. Exactly 12. Between 10 and 15. So equals the higher one, so 15, 12, true, minus lower one, but instead of 10, it's going to be more than 9. It's 15 and 9, because the lower one you do 1 minus that. Part E. smallest integer such that we can be at least 99% sure that the annual number of accidents occurring will be less than k. %99% sure it will be less than k. 99%. Probably like, what, 20? We're going to go Poisson.dist. It's less than 20 with a mean of 12. True. Hey, look, that was pretty close. So we want it to be at least 99% sure. It only took me 2 guesses to get the right answer. So we have a 99.4% sure that we will have less than 21. We are 99% sure it will be less than 21, right? That was funny, but... So, apparently the song is famous or something. Like, why? Just why? Why is this one famous? Probably less than k. Wait. Find the smallest integer that you'll be at least 99% sure it will be less than 21%, or 21. It'll be less than 21 because we already got 21 there. Because we're only 98% sure it'll be less than 20. So there. We did it. Stop. We're done with part number 44. We're done with number 44. We're now 6 out of 10. Let's open number 45 because opening it is much... What? Wait. Okay, for some reason it doesn't even have all of them here. Or maybe they're out of order. Probably. Yeah, they're out of order. But anyways, here, 40... What? 44... I said we're done with 44, right? We just did 44. Now we're doing 45. We want to do 45. Jeez. We're doing all of these? Why? Why are we doing so many Poisson questions? Well, I mean, Poisson questions are pretty easy, so maybe I shouldn't be complaining, but why are there so many questions? Why are we doing all these questions? I was gonna. Anyways, bye.